This is section 1.3, part B, measuring spread, the interquartile range. A measure of center alone can be misleading. The mean annual temperature in San Francisco, California is 57 degrees Fahrenheit, the same as in Springfield, Missouri. But the wardrobe needed to live in these two cities is very different. That's because daily temperatures vary a lot more in Springfield than in San Francisco. A useful numerical description of a distribution requires both a measure of center and a measure of spread. The simplest measure of variability is the range, which we defined earlier as the difference between the largest and smallest observations. The range shows the full spread of the data, but it depends on only the maximum and minimum values, which may be outliers. We can improve our description of spread by also looking at the spread of the middle half of the data. To do this, we're going to count up the ordered list of observations starting from the minimum. The first quartile, or the Q1, lies 1/4 of the way up the list. The second quartile, which is the median, is halfway up the list. And the third quartile, or the Q3, lies 3/4 of the way up the list. So if we want to find the range of just the middle 50% of the data, we would take our third quartile minus our first quartile, and we would find the range of the middle 50%. These quartiles mark out the middle half of the distribution. The interquartile range, which we will call the IQR, measures the range of the middle 50% of the data. So how do we calculate the quartiles? To do this, you're going to arrange the observations in increasing order and locating the median, or the M value, in the ordered list of observations. The first quartile, Q1, is the median of the observations whose position is to the left of the median, and the Q3 is the median of all observations to the right of the median. The interquartile range is found by taking your Q3 minus your Q1. So we need to find our Q1, our median, and Q3 of this distribution. Now we know there are 15 workers, so we know that since this is odd, we can find our median value. 15 divided by 2 is 7.5, so we need to go past the 7th into the 8th data point. So if we count over 8 points, we know that this value will be our median. Now, to find our Q1, we are going to look at the data to the left of our median, and we need to find the middle. Now, we know that we have 7 data points to the left. 7 divided by 2 is 3.5, so we need to go to the 4th data point. So 1, 2, 3, 4. This will be our Q1. And on the right, we have 7 data points. Again, 7 divided by 2 is 3.5, so we need to find our 4th data point, and this would be our Q3. The quartiles and the interquartile range are resistant because they are not affected by a few extreme observations. For example, the Q3 would still be 31 and the IQR would still be 20 if our maximum value was 600 rather than 60. But if we change that maximum value to 600 instead of 60, if we only looked at the range, our range would go from 55 to 595. In an earlier example, we looked at data on travel times to work for 20 randomly selected New Yorkers. Here is the STEM plot once again. We need to find and interpret the interquartile range. Now we know there are 20 observations. 20 divided by 2 is 10, so we need 10 observations to the left and 10 observations to the right. So if we count in, the 10th observation is 20, the 11th observation is 25, so we know our median will fall between there. Now we have 10 data points to the left and we have 10 data points to the right. To find our Q1, we're going to find the middle of the first half, and on the Q3 is the middle of the second half. So if we have 10 data points, it's going to fall between the 5th and the 6th value. So it's going to fall between 15 and 15. So our Q1 is 15. Our Q3 will fall between, on the data values to the right of the median, between the 5th and 6th value. So it's going to fall between 40 and 45. So since it falls between the two, we will have to find the average of those numbers, and our Q3 would be 42.5. To find the IQR, you are then going to take your two values, your 42.5 and your 15. You will subtract them, and you will have an interquartile range of 27.5 minutes. This means that the range of the middle half of the travel times for New Yorkers in the sample is 27.5 minutes. Again, with statistics, you can't just tell me the IQR is 27.5. You have to have units, and you have to put it back into the context. In addition to serving as a measure of spread, the interquartile range is used as part of a rule of thumb in identifying outliers. So to find outliers, we do 1.5 times the IQR rule. We're going to call an observation an outlier if it falls more than 1.5 times the IQR above the third quartile or below the first quartile. So let's look at the North Carolina travel times again. We need to determine whether this value of 60 is actually an outlier. So the first thing we need to do is we need to find the median. So if we write these values in order, we have 5, 10, 10, 10, 10, 12, 15, 20, 20, 25, 30, 30, 40, 40, and 60. Because there are 15 data points, we know it is going to be the 8th data point that is the median. To the left, there are 7 data points, so our Q1 will be 10. To the right, there are 7 data points, so the 4th one in that list will be our Q3. So in this case, we know that our IQR is going to be our Q3 minus our Q1, which is going to give us an IQR of 20. To determine if there's any outliers, we are going to do Q1 minus 1.5 times the IQR. If any data values fall below what we get there, then we know they're an outlier. And we're going to do Q3 plus 1.5 times that IQR. If any data values fall above that value, they will be outliers. So our Q1 we know is 10, and we're going to do 1.5 times that IQR. Or, in this case, it's going to be 10 minus 30, which gives us negative 20. So we know anything that is below a value of negative 20 minutes would be an outlier. We do the same thing with our Q3. We're going to do our Q3 plus 1.5 times our IQR, or 30 plus 30 is equal to 60. So any data value that is larger than 60 would be an outlier. Since the longest travel time is exactly 60, it does not qualify as an outlier. An AP exam tip: you may be asked to determine whether a quantitative data set has any outliers. Be prepared to state and use the rule for identifying outliers. So make sure you say you're using the 1.5 times IQR rule. The smallest and largest observations tell us little about the distribution as a whole, but they do give information about the tails of the distribution that is missing if we know only the median in the quartiles. To get a quick summary of both center spread, we can combine all 5 numbers. So if we are looking at a 5-number summary of a distribution, it's going to contain the minimum, the Q1, median, Q3, and the maximum. The 5-number summary of a distribution leads to a new graph, which is the box plot, or sometimes called the box and whisker plot. To make a box plot, a central box is drawn from the first quartile to the third quartile. A line is drawn in the box to indicate the median, and lines, which are called whiskers, are extended from the box out to the smallest and largest observations that are not outliers. Any outliers are graphed by a dot that is past the end of the whisker. So Barry Bonds set the Major League record for hitting 73 home runs in a single season in 2001. On August 7, 2007, Bonds hit his 756th career home run, which broke Hank Aaron's long-standing record of 755. By the end of the 2007 season, when Bonds retired, he had increased the total to 762. Here are data on the number of home runs that Bonds hit in each of his 21 complete seasons. We need to create a box plot for the data. So the first thing you would need to do is to arrange the values in order from smallest to largest. So the smallest number is 16. In the 20s, we have 24, 25, 25, 26, and 28. In the 30s, we have 33, 33, 34, 34, 37, 37. In the 40s, we have 40, 42, 45, 45, 46, 46, and 49. And his best season, he had 73. So we have them in order from smallest to largest. First thing we need to do is find the median. That median is the middle number. Now 21 divided by 2 is going to give us 10.5. So it is going to be the 11th data value. And the 11th data value is 34. We now have 10 data values to the left and 10 data values to the right. So if we have 10 data values, we need to find the value between the 5th and the 6th data point. So our Q1 is going to be between 25 and 26, or our Q1 is going to equal 25.5. Our Q3 will be of the data values to the right of the median between the 5th and 6th data point. So between 45 and 45, or our Q3 will be 45. To make our box plot, we need to determine if there are any outliers. So we still need to do our IQR. Then we need to see if there are any outliers. So you are going to do Q1 minus 1.5 times the IQR. And you are going to do Q3 plus 1.5 times the IQR. Now, our Q1 is 25.5 minus 1.5 times our IQR of 19.5. And our Q3 is 45 plus 1.5 times our IQR. By doing this, we are going to see that any value that is less than negative 3.75 would be an outlier, and any value greater than 74.25 would be an outlier. Since that range of values have nothing outside of them, there are no outliers. So when we go to make our box plot, the first thing you need to do is create a number line. You will make a box that goes from Q1 to Q3. You will put a line in that box where your median is located. You will put a dash where the smallest value is that is not an outlier, which in this case is our median, and draw a whisker back to the box. And you'll put another dash where the largest value that's not an outlier, which in this case is the maximum is, and draw a line back to the box. Box plots show less detail than histograms or stem plots, so they are best used for side-by-side comparison of more than one distribution. Be sure to discuss the shape, center, spread, and outliers as part of your comparison. So if we are comparing the travel times of North Carolina drivers to the New York drivers again, the first thing we look at is their shape. We see from the graph that both distributions are right skewed. For both states, the distance from the minimum to the median is smaller than from the median to the max. When we look at the center, we're using the median as the center mark. We can see that the travel time in general is longer for New Yorkers than North Carolina because the median is higher for New York than in North Carolina. The Q1 is higher for New York than North Carolina, and the Q3 is higher for New York than North Carolina. The spread, the travel times are also more variable in New York, as shown by the height of the bars, or the height of the boxes, which is the IQR, and the spread from the smallest to the largest. Neither of the datas have any outliers, so there are no outliers to discuss. Now we can make box plots on a calculator. If you use a TI 83 or 84, you can put the data into your calculator and make your graphs. So the first thing you would need to do is enter the travel time for North Carolina drivers into list 1 and New York drivers into list 2. Remember to do that, you would have to go back to your stat editor. Next, you would set up two statistical plots. Plot 1, you want to show a box plot for North Carolina, so you would turn plot 1 on. You would select box plot. Now there are two different box plots that you can choose. You want to choose the one that has the outlier option. You need to make sure plot 1 is for list 1. Then you can go over to plot 2, turn it on, make sure it's also a box plot with outliers, and make sure it is on list 2. We can set our graphs to fit the window properly by hitting zoom, selecting zoom stat, and it will graph the two box plots. You can then trace your box plots by hitting trace and then moving the arrows to the right and the left to see where the different quantities are found. The 2009 roster of the Dallas Cowboys professional football team included 10 offensive linemen. Their weights in pounds were given. Find the 5-number summary for these data by hand and show your work. So remember, to do this, the first thing you have to do is you have to put them in order from smallest to largest. Once they're in order, the minimum is just your smallest value, the maximum is your largest value. To find the median, you find that middle number. Because there are 10 of them, it'll fall between the 5th and 6th data points. So because there are 2 of them, we're going to add those two values together, divide by 2, and we'll get a median of 31.75. We now have 5 data points to the right of the median and 5 data points to the left of the median. So of those 5, you're going to find the middle. So our Q1 is 311, our Q3 is 326. Calculate the IQR and interpret this value in context. To find the IQR, remember you're going to do the Q3 minus the Q1, or 326 minus 311, which in this case will give us 15. So that means of the 10 offensive linemen, the range of weight among the middle 50% of them is only 15 pounds. Determine whether there are any outliers using the 1.5 times IQR rule. So we know that our IQR is 15, so we would do Q1 minus 1.5 times the IQR, and we would do Q3 plus 1.5 times the IQR. Our Q1 is 311, and our Q3 is 326. That is going to give us that we can go down to 288.5 pounds, and we can go up to 348.5 pounds without having any outliers. Now, if you look at your data set, we don't have any values that are less than 288.5, but we do have a value that is greater than 348.5. So we would say the person who weighs 353 pounds is an outlier. Now we need to draw a box plot of this data. To do this, the first thing you do is you make your number line, your horizontal axis. Then you would put your box from your Q1 up to your Q3. You put a line where your median is. Since we do have an outlier, we are just going to put a dot where that outlier is. Our whisker on the right will just go to the next largest number, which is in this case 338. Since there are no outliers on the left, that will just be our minimum number of 307.